Hello, in this lecture, we are going to discuss one of the questions that came in TFR exam of 2019. A few similar questions have come in the examinations when like examination like JEST or NET also. You might see such questions have been asked quite many times. Okay, so today what I'm going to do is I'm going to teach you how to go about how to do these questions. Okay, so this is fairly easy, but let us first develop the context. So the question simply says it actually is asking us to evaluate this kind of improper integral. And here you see that there is a Dirac function. So basically, everybody knows, as I have already taught, but still, if you're not aware, Dirac function is given by an infinite spike at x equal to 0. And whenever x is not equal to 0, it is simply equal to 0. So basically, what does it represent? It represents the entire thing. Okay, so the entire thing uh, is actually like entire contribution is coming from one single point. So for example, whenever it comes to the description of point charge, point mass, we use such function called as Dirac delta function. Now question arises that if I have, instead of x, the argument of this Dirac delta function is, let's say, g of x, that is some function. Okay, if it is some function, then what to do? Okay, now it first thing that I need to tell you here is that first thing, it will make sense only if it will make sense. What will make sense? That I'll talk to you later. But Dirac of g of x, it will make sense only if gx has simple zeros. Has simple zeros. Okay, so by simple zero mean, let's say I have a function fx equal to x minus 3. So this is a simple zero. Here x equal to 3 is a simple zero. But if I consider fx equal to x minus 3 whole squared, so here you can write that x equal to 3 is a double root or a double zero or a zero of multiplicity 2. So here it is not a simple zero. It is not a simple zero. Okay, this is first thing that you should understand. Okay, another thing that I need to write here is, let's say, if what do we mean when I say that there's something called as repeated zero. For example, if you take the derivative, again you will find that x equal to 3 is a 0. And if you take the double derivative, you'll find the answer is 2, that is non-zero constant. So it will come out as a non-zero constant at x equal to 3. So if you have to, this defines the multiplicity. So at whichever level of the derivative or whichever order of derivative your function on which you are actually scrutinizing that that particular function has a repeated zero, you have to just differentiate it, and whichever order gives you a non-zero answer, that particular order becomes the multiplicity of the root. So here, if I say that x equal to 3 is a root of multiplicity 2, what does it imply? You just differentiate fx twice and you'll find that you'll get a non-zero constant. Otherwise, all the lower order derivatives will be 0 at x equal to 3. The first thing that one needs to remember, that Dirac of g of x will make sense only if g of x has simple zeros. Okay. Now question arises, what if it does not have a zero? What if it does not have a zero? Then it would be 0 simply. Because you understand that Dirac of x is equal to 0 if x is not equal to 0. Now, if g of x is non-zero for all x belongs to the domain of g, then Dirac of g of x would certainly be equal to 0. So you don't need to worry about it. And if g of x has repeated 0, then it does not make sense. I'll write it here. If g of x has multiple zeros, then whatever I'm going to teach you today does not make sense. Multiple zeros, then Dirac of gx does not have any meaning. You just have to remember all these things, whatever I'm writing as a point, because right now my focus would be to solve the question. Okay, does not have any. Just remember these slight points before we head on doing the question. Now, see, whenever you have this kind of function, so for example, now if let's say g of x has a simple root at xi, let's say xi is that simple root of gx, then what I can do, I can approximate this particular thing as simply g of xi plus x minus xi times g dash xi and then I can have all sort of higher order derivatives also. So I'm not concerned there. I'm just neglecting all these higher order derivatives, and I would be taking it account of the linear approximation of g of x. I clearly know that xi is the root, so clearly gxi would be 0. So gx can be linearly approximated to x minus xi and g dash xi. And I've already told you that xi is a simple 0. If xi is the simple 0, then g dash xi has to be a non-zero constant. It has to be a non-zero constant. So it has to be a non-zero constant. And if you remember the scaling property in the Dirac delta function, Dirac of ax is simply Dirac of x divided by modulus of a. For better, you can just go on to my lectures on Dirac delta function. You will find that I have derived this particular property. This is called as a scaling property. So basically, g dash xi being a constant, constant, having a constant value. So what will happen if I just write Dirac of g of x? It will be simply equivalent to writing. Okay, these can be many, like it can be possible. Let's say, for example, you have this function f of x is x minus 1 into x minus 2 into x minus 3. So all these points 1, 2, 3 will be called as a simple zeros. Okay, so first thing is that these xi's should be simple zeros. So if I write g of xi, if I write Dirac of g of x, the Dirac of g of x would be equivalent to writing Dirac of g dash x into x minus of xi. And what does it imply? It will be equivalent to writing x minus xi divided by modulus of g dash xi. Okay, so Dirac of g of x is nothing but it is equals to Dirac of x minus xi divided by g dash xi. Let's say if these i's are n in number, then we have to sum it all over. Okay, so if there are, let's say, n simple roots to this g of x, then this will be the formula. Okay, this would be the formula. Now let us try to do the question. Now let us try to do the question that has been asked. Okay, just give me a minute. Okay. Okay, so the question that was asked in the examination was, this was the question. So let me just copy it so that it will be easy for us to evaluate this question here. Okay. Okay, so this has also come along. Just okay. So the question is quite clear to you, I hope. So just okay. So here it is. So this was the question. Now let us try to do this question. So first, let us try to get rid of this particular thing. So for example, if I'm writing Dirac of sine of x, all you need to know is where are the simple zeros of sine. The simple zeros of sine are at x equal to n pi, where n belongs to z. And especially since we are integrating from 0 to infinity, so we only take the positive and so I'm going to take x equal to 0, x equal to pi, x equal to 2 pi, x equal to 3 pi, so on and so forth. So since we are integrating x in the range from 0 to infinity, so basically the allowed values for x will be from 0 to infinity. So I'm going to take all the points where sine x would be 0 on the positive x-axis. So on the positive x-axis, you know that x at 0 would be, if x is equal to 0, then sine x would be 0. If x equal to pi, then sine x would be 0. If x equal to 2 pi, then sine x would be 0, so on and so forth. So basically, this would be equivalent to writing n belongs to z, n belongs to z, and this will be x minus of n pi divided by cos n pi modulus. Why cos n pi modulus? Because you see, the formula to it was Dirac of g of x is simply equivalent to writing summation I equals to 1 to capital N. And what are these? These are nothing but these are the, sorry, xi's are what? Xi's the simple, xi's are the simple roots of g of x divided by g dash xi. And what is g dash xi? So basically g dash xi would be cos x, because here instead of gx, sin x is given to you. So the derivative of sine of x would be cosine of x. So derivative of sine of x would be cosine of x. And if you place n pi there, so I know already that cos n pi is equal to minus 1 raised to power n. So what would be cos n pi modulus? Cos n pi modulus would be simply 1. Okay, is that clear? I hope it is clear. Just give me a minute. Okay. Okay. So now you see cos n pi modulus will give you a 1. So if I want to write what would be my Dirac of sine of x, so my Dirac of sine of x would be simply summation n belongs to, let's say, not z, in fact, I would write n belongs to natural number union 0, Dirac of x minus of n pi divided by 1, because cos n pi is simply, cos n pi modulus is simply 1. Okay, now you see, if I want to integrate the stuff, so what is the integration? Integration is from 0 to infinity dx e to power minus x Dirac of sine of x. And what it would be equal to? It would be equivalent to writing n belongs to natural union 0, and then you have this integration from 0 to infinity, and this is dx, and then you have this e to power minus x, and this is Dirac of x minus of n pi. Okay, now remember, one of the properties is like, if you have minus infinity to plus infinity, if I'm integrating fx, and along with it I have this Dirac of x minus x naught, so this particular argument, whenever it becomes 0, so here it becomes 0 at x equal to x naught, the integration of this particular thing is given by f of x naught. So all you need to replace is the 0 of the argument of the Dirac delta function. So inside the function, you have to replace x by the 0 of the, or you can say the 0 of the argument of the Dirac delta function. The argument of the Dirac delta function x minus x naught becomes 0 at x equal to x naught. So basically this integration happens to be f of x naught. So this is at times referred to as the filtering property. And if you see, if I integrate this up, so basically what is going to happen? E to power minus 0 will come. Then see, all these points are there. So x belongs to n union 0. So first, it will be, I'm just writing it for you. It would be like dx e to power minus x. And this will be, since sums are happening, so this will be Dirac of x minus pi plus Dirac of x minus 2 pi plus Dirac of x minus 3 pi, and so on and so forth. So basically it will give you e to power minus pi, then it will give you e to power minus 2 pi, then it will give you e to power minus 3 pi, then it will give you e to power minus 4 pi, and so on and so forth. And eventually, what will happen? It will give you 1 plus e to power minus pi plus e to power minus 2 pi plus e to power minus 3 pi plus e to power minus 4 pi, and so on and so forth. And if you remember, if I have this arithmetic, if I have this geometric series of infinite terms, then this particular series, if I am extending it to till infinity, then the sum of these infinite terms turns out to be a upon 1 minus r, where mod r is less than pi. So here r is equals to 1 upon e to power pi. So answer would be 1 upon 1 minus e to power minus pi, and simply I can write it as e to power pi upon e to power pi minus 1. Okay, so this happens to be the answer, and I hope you've got this particular question. So the answer is C, which was given in the TFR answer key as well. So basically, these are very easy questions, and you just try to solve a few questions. The similar questions have been asked in JEST examination, NET examination. So I hope I've been able to tell in very brief the concept and the question. Please do let me know in whichever section of the physics you are having problem. I'll try to solve it for you. Till then, take care. Bye-bye.